so now in this problem, I'm not giving you the zeros, I'm giving you the factors. So we need to remember, how do factors compare to zeros? So I'll just do a quick little example. Let's just pretend I had a negative x squared minus 5x plus 4. Let's say that was my function. And if I wanted to find the zeros, let's see, I would have to first set this. If I want to find the zeros, I convert this to 0. And then I say, I factor this, which would be x minus 4. No, times x minus 1. Then, these are what I call my factors, right? Because my factors multiply to give me 0, so therefore my zeros, which are my solutions to this, I set equal to 0. So I take each factor and I set them equal to 0. Because I use that by the zero product property. Therefore, I can say my zeros are x equals 4 and x equals 1. Those are my zeros, and then here are my factors, which you can see right here. Now, when given the factors, what we want to do is we want to find the zeros. And besides just looking over at the zeros, the reason why we want to use zeros is because we want to apply synthetic division. You could also multiply these factors and then use long division if you want to, but I don't know too many students that really like using long division, so I'm going to stick with synthetic. Alright, so when sticking with synthetic division, if you have two numbers that divide into a polynomial, or two factors that divide into it, it doesn't matter which factor you choose, you can choose either one. Now remember, when given a factor, what we like to do is take that factor and convert it to our zero. So we set it equal to 0, and then we solve. So x equals negative 2 will be the first one I'll choose. So I'll do negative 2, then I set up my synthetic division. I need to make sure that my polynomial is in descending order, and then I list my coefficients. Alright, so now what I'm going to do is I'm going to apply synthetic division to find a remaining factor. So the first thing I do is I bring down 8. 8 times negative 2 is going to be a negative 16. Negative 16 plus negative 14 plus negative 16 is going to be a negative 30. Negative 30 times negative 2 is going to be a positive 60. Add vertically, negative 71 plus 60 is going to be a negative 11. Multiply it across, negative 11 times negative 2 is going to be a positive 22. Negative 10 plus 12 is going to be a positive 12. 12 times negative 2 is going to be a negative 24. And that set is going to equal 0. Therefore, if this is my factor, this factor divides evenly into this polynomial, remainder, constant, linear, quadratic, cubic. So it's going to divide into there 8x cubed minus 30x squared minus 11x plus 12 times. Now, to find the remaining factors, I would have to factor this. Now, this does not look like a fun problem to go ahead and try to factor. I automatically would look at this and see if I could do grouping, and it just doesn't look like it's even going to work as far as with grouping. Fortunately for us though, they're giving us another factor. So what I can do is I can break down this larger factor again by making sure I use the other factor to simplify it. So therefore, I'll take my 4, and now what I'm going to do is I'm going to synthetically divide, but now I'm going to choose my resultant factor. So I'll choose 8, negative 30, negative 11, and 12. Now I apply synthetic division again. Bring down the 8. 8 times 4 is 32. Negative 30 times positive 32 is a positive 2. 2 times 8 is positive 8. Negative 11 plus 8 is negative 3. Negative 3 times 4 is a negative 12. 12 plus negative 12 is going to be 0. So that's my remainder, constant, linear, and quadratic. So now I know I've determined that negative 2 is a 0. We already know that. Positive 4 is a 0, and of course, why didn't I use negative 4? Because remember, we set our factors equal to 0 to find the 0. So I add 4, so x equals 4. So that's why I use 4 in there. However, there's two more factors, and how do I know there's two more factors? Because we have our polynomial is raised to our 4th power. So there's two more factors that we can go ahead and find. So what I need to do to find those is now I need to factor 8x squared plus 2x minus 3. Alright? And to do that, there's a couple different ways we could do that. And remember, this is another factor, so we can set it equal to 0 to find the other zeros. So to do this, there's two different options we have. Alright? We could have 8x times x, or we could have 4x times 2x. Now remember though, these two terms have to multiply, or our last two terms have to multiply to give us negative 3. That means one of my other terms, one of my factors for 3 has to be negative. So it's either negative 3, negative 1, or it's positive 3, negative 1. However, if we look at our middle term, we notice that the middle term is positive. Therefore, we know that the largest factor, or not necessarily the largest factor, but this largest sum has to be positive. But when we look at this, even by multiplying them, yeah, one of my factors actually still could be negative. So let's go and just apply. I'm just going to plug them in and see if they would work. Let's do, how about we do -1, -1, positive 3, positive 3. All right? We know that by multiplying the first and the last, we're going to get these two terms. But what we want to do is multiply the middle and the last terms to see if those add up to give us 2x. Well, 8x times 3 is going to be 24, so I already know that's going to be way too big, not going to work. 4x times 3, that's going to give us 12x, that's going to be way too big. So let's rewrite these then. Let's change this to a positive 3, negative 1. Positive 3, negative 1. Now I apply the same thing. Well, yes, 8x times negative 1 is negative 8x, plus 3x is a negative 5x, not bad. 4x times negative 1 is a negative 4. 3 times 2 is a positive 6x. So positive 6x plus negative 4x is a positive 2x. So therefore, that is going to be our factored form of this factor. Now, I know that since this is a factor of the polynomial, I set it equal to 0. Now I can apply the zero product property to find my remaining zeros. And then I solve. Subtract 3, divide by 4, x equals a negative 3/4. Add 1, divide by 2, x equals a positive 1/2. So there you go, ladies and gentlemen. You now have with your original, there's your two factors. So we already know where you have x equals negative 2 and x equals positive 4. So that's going to be your solution set now of all of your factors, given your factors of a polynomial. We have now just found all the zeros. Thanks.